We have a completely open agenda for the day. The past couple of agendas, we spent time on the white paper that we've been working on. So that's an option to go back to that as well. Otherwise, if people have other agenda items they'd like to add, feel free to add them to the document or throw them out here and we can discuss them. And then if none of that comes up, we can also just kind of get updates from people on some of the stuff in the space that has been interesting them.
Yeah, we can go and jump to the white paper. Excuse me for my voice, got a bit of a cold. We can jump to the white paper real quick, but Andy did a ton of updates, also reflecting your comments, Victor. But I don't really see Andy here, which might be useful to have him, right? For that particular discussion. But I at least know what the edits are. We can go through them at a high level if you like. If there's no other topic that we want to go and discuss.
Do folks have other ideas that they would like to throw out there or announcements as well? Okay, let's do that, Frank. Let's look at some of the updates and continue on with that. And then if any time between that, people have also other topics that they want to throw in, we can timestamp that white paper work as well. With that being said, do you want to share your screen, Frank, or would you like me to?
I can go and try to do that. Let me go and try to do well, the host disabled screen sharing for me. So somebody would need to go and give me rights to do that.
Yeah, I think we're
we're
unable to do that at the moment. Yes. So we're going to have to use very descriptive words for the time being.
Does anybody have sharing rights, or maybe could anybody try whether he can go and share or she can go and share?
Doesn't work for me, what it's worth.
Yeah, I think it's not going to work for any of us. So
it wouldn't work for anybody. Okay.
Why don't we try, Frank, to just follow along, and then while we're doing that, I'll look into it. I know I have the keys. I just need to learn.
So what we can try to do is, maybe we do it the way. Am I at least able to go and put the link in? Yeah, well, you put the link there already. Excellent. So I think the main thing is if we go to the section that carries the title Edge Native Application Design Behaviors. This is where, Victor, you put the comment around, I believe at last meeting that I unfortunately missed because I was traveling. You discussed a load around the various, how does location correlate in here with the different edges that were identified. And that is also like this picture that was taken from the original LF Edge white paper, this sharpening the edge overview of the LF Edge taxonomy and framework. And so seemingly that created a bit of confusion. And what Andy did and taken the pen is if you roll a little upwards into that section that is right below this picture that is this overview and taxonomy framework with the user edge, the service provider edge, and the centralized data centers edge. In order to resolve the confusion here is that the type of edge is largely, orthogonal to how you design an application for an edge, because the principles that we have been talking here, and that's what Andy is saying, are more with regards to, do I need to overcome certain constraints at the edge, like low bandwidth, limited or design constraints from a delay perspective, frequent outages of the uplink, or certain policy considerations that require the application to stay at a particular location. And all of these could obviously apply to the constrained device edge. They can go and apply to the smart device edge. They can also apply to the access edge or regional edge. So it's not so much what type of edge it is. It's more like what are the capabilities or the qualities of that particular edge on whether cloud native design principles apply, or whether some of the cloud native design principles need to be evolved. And that's, I think, what we all call edge native, right? That we need to go and apply these edge native design behaviors in that case, which is another set or additional set of considerations. So that it's not so much like edge native applies to this particular type of edge and it doesn't really apply to that particular type of edge. We're basically saying, well, it could go and apply to all types of edges, depending on what the qualities are of that particular type of edge. So it's an orthogonal set of considerations that need to kick in. And if you would go and consider that thing as a kind of a topology or a landscape, it could well be that in certain areas, it could be a smart device edge that needs to go and consider edge native design principles. Or in other locations, it could even be an access edge that needs to go and consider edge native design principles, just depending on where this is, where it's located. Like if this access edge is, say, located on a vessel, then edge native design principles might apply. If the access edge is like high bandwidth connected with fiber, dual homed on whatever, at a particular location in the country, then it might not apply, right? So I think that's what we're trying to go and say, or that's what Andy, I think, put into some very nice words in this section to go and resolve the confusion between the anticipated confusion around the different types of edges that were qualified in an earlier paper by LF Edge and the application design behaviors that we're talking about here. And it's still in the process of being evolved, as you see, like certain areas in this table for considerations and the likes are still being filled out. So this is far from done, but I just want to go and check, and I'm paraphrasing Andy, obviously, here, whether Victor, that would go and address what you had in mind or what the confusion seemingly was in the last meeting. As again, like I'm kind of talking this.
Thanks for the.
I missed the last meeting because it's a little bit of an odd situation, right? Because Andy is not here, and so I'm talking on behalf of Andy about something that happened in a meeting that I wasn't here for. So, but maybe I'm making sense. I'm not sure.
So I think it's more. I think that terminology edge is definitely not very clearly defined. I also depend on the background. Like, for example, I'm more of a traditional, really the classic database guy. So for me, the old time edge computing means now we have public cloud. Let's say public cloud is the center, right? So edge means even for customer customers to public cloud, right? They're their own data center. That's also considered edge, right? So, but in that case, the edge has almost exactly the same connectivity, speed and all that, and it doesn't even involve IoT and all that. So if the white paper says it's IoT edge, that will probably be more, I guess, specific for what's described in that paper. Because if you say edge native, that edge could be just a customer data center, and that's still called
correct.
edge.
And that customer data center, that's the point we're trying to go and make in that section below. If you look at the latest updates of the white paper, as we're trying to go and make in that section below this taxonomy picture, so that for some customers, indeed, like a customer data center is an edge, and you can go and operate it and run it, and you can go and build applications for it like cloud native, because it's well connected. It doesn't really face any location specific constraints, and that's okay, right? That's what we're saying. And there's nothing specific that you would need to go and consider. But if that particular customer data center, as I said, like is a customer data center that is situated on a vessel, and that vessel is crossing the Pacific, then suddenly, like, there might not be connectivity on the vessel for a particular point in time. And then it might well be that edge native application design behavior needs to go and apply. Because you need to have the application deal with the fact that it's not always on, that it's not always connected. So what we're trying to go and say in this short paragraph, and maybe we should go and make it even or expand it even further, is that the type of edge doesn't necessarily mandate how you design applications. It's an orthogonal consideration what type of edge that you have and how you design applications to it, because the application design, or whether it's edge native or cloud native, really depends on what level of constraints you're facing for that particular environment. And that means sometimes it can be a large edge or it can be a very small edge. In many cases, the small edge is more constrained, but doesn't necessarily need to be, right? It could be a small edge that has fiber to the small edge, really good connectivity, will be always on, dual homed, just because it's situated in a metropolitan area where there's really no limitations to the whole thing. So I think that's what we're trying to go and express there, that there is, yeah, this type of edge is somewhat like different from the application design principles that we're discussing.
Yeah, I said it's a. I think that the edge. I got what you're saying. It's just that the edge computing concept itself is just defined in multiple ways, and I'm just trying to, I guess, get a grasp of myself.
And that's what we're struggling with here. I fully understand that, and which is why we probably need maybe even more. Like that's why we started building this table. And as I said, like not all the considerations have been filled in. That's something that Andy is still working on, but that is really to help. Well, make sure that there is a common understanding that these design criteria are trying to overcome certain constraints. And if these constraints are not there, then we don't need to worry. And these design constraints can be there if you're very far from the central cloud, and you can be very close to the central cloud, but that doesn't really matter because you can still face these constraints. And the design behaviors are just to overcome these constraints around latency requirements, bandwidth requirements, availability, and the likes.
Another area that's similar, related, but not about edge computing is telecom, right? So because I worked as a database guy in a telecom company before, so nowadays, like for example, the Open RAN Alliance thing. There's so many different standards. They're like ranging from Linux Foundation to, not Linux Foundation, Open Network Foundation. Each one have their own sort of RAN configuration technology, and so so when you're talking about application, to me, working for telecom, sometimes it means one of the component within that the telecom base station and things like that, right? So that's also sort of sometimes not even constrained by networking connectivity, but it's some other different kind of constraints. So yeah, it'll be, I would say it'll be nice to have a uniform definition for that. But right now, the definition from like the RF edge, the definition from the traditional edge, yeah, all that is a little different. That's the hard part.
And we're not trying to go and define edges again here, right? This is more like, as I said, like, what if cloud native application design principles don't really work anymore for a variety of reasons? So these constraints that we've just been discussing, what do I need to go and do differently from an application design perspective so that I can go and deal with these constraints? And I think that's what we're trying to go and solve in that white paper.
maybe can I say that this is probably just IoT edge? Can it be, maybe that's the more clear definition of edge for this paper?
As I said, no, really, right? If you put a data center onto a vessel, then the white paper applies.
Oh, okay. I see what you're saying. Yeah. Okay. Yeah. True.
That's the problem. That's the little trap that we laid out for ourselves.
It could be data center on Mars or Moon.
Yeah, if we put a data center on Mars, then we probably need to go and deal with similar considerations.
This
even
is
worse. So when the data centers, whenever you're rotating, you have intermittent connectivity. Whenever the data center faces the Earth, then you'll have connectivity. And then if you're on the dark side of the Mars or the Moon, then you won't have connectivity. And so, yeah, even if you put a large data center there, edge native would very likely apply. So I think that's why we're trying to go and not call it something that has, well, linkage to this taxonomy, because otherwise, like we're basically talking about something that is orthogonal here.
This reminds me of a discussion that we had when we were making the edge native application principles, when it's impossible to start any edge initiative without debating over the definition of edge. And we found that there were three kind of categories of definitions. One was location-based edge, which or geography-based edge, namely how far is the data from the user. The second was network-based edge, which is kind of sounding like we're getting here with how connected is that device to a network and what is it, the behavior of connectivity. And the last was resource-based edge. So how edge is it means how many resources are around it and how important is that to it as a system. So is it the last server near all these IoT devices, or does its environment instead look like a data center, but it's actually just kind of disconnected or in a different facility? So it's sounding like this one, it's sounding like the majority of the design behaviors need to change based off of a network-based definition is what it's sounding like.
Yeah, it's network and it's partially data as well. It's also like it links to the resources and it also links to policy, right? Policy and security considerations. You can go and fold that into the three things that you mentioned. I think all of that obviously overlays with policy. You can have network policy, you can have data policy. Well, policy on resources, maybe not so much, but yeah, I think there is, again, like there's a different set of classifications, and we just said, well, if you face certain constraints and we go through these constraints and also overcoming them, maybe we would need to go and re-articulate the constraints even as a bulleted list and describe them a little further. Maybe that's another approach to clearly nail the topic here. But I actually like this data, resources, and networking. So actually, it's probably easier than like the taxonomy that is more like a business taxonomy that LF Edge originally set out. It's like who owns the edge or who operates the edge, which is natural for some and not so natural for if you're a software developer, you actually don't worry too much on who owns the edge, but what environment do I find there, and what can I go and take as a given, and what can't I take as a given when I need to go and design my application accordingly, right?
Yeah, I think this gets to the question of, is the solution, and it seems like the problem here is how do we define what these application behaviors should be when an application here is so different, so varied, because edge is very varied. And I'm wondering if one mention that Victor said was scoping the definition to IoT, or would another option be to kind of create a spectrum of issues and allow every design behavior to be targeted to a certain issue? So you only need to have data persistence if you're worried about your storage capacity. These types of applications tend to have a lot more storage resources, and these ones tend to have less. I don't know if there's a way to kind of point people through it, almost like a dichotomous key, like, is this your issue? Go here. If not, go here. Yeah,
so what you're hinting at, and that's something that we can go and try, right? Maybe that's even an evolution of the table that we started, right? We're still trying to go and see how we best describe the elephant in the room. But maybe we come up with a table where we say, well, and I think Joel was thinking the same way earlier on, where we had different capabilities that you need to go on, different design behaviors based on the constraints that you're facing, so that you can check them off or not, like applies, doesn't apply. If you don't worry about storage, like because everything is anyway stateless, then well, it doesn't apply at all, right? So yeah, maybe I think that's a good idea. We should go and we can go and try. Let me see how far we can go and get if we craft a table, and whether it's not getting too busy or whether there's indeed like a fair amount of diversity that the table would express. I think it's
because I'm a database guy. Sorry, maybe it's because I'm a database guy. I'm kind of when it comes to stateless, my understanding, at least the edge I deal with, usually involve database. That's probably why when I have a like edge location, even if it means that data center on a machine, right, having a really stable backup recovery mechanism is more important than like a regular edge. You know, like if you're in a data center, you have backup constantly running backup can be restored in a cloud, right? So when you have a data center, right, that's right on like a machine on a ship, that having a solid backup recovery stable is even more important. So instead of being stateless. It might be just because yeah, every edge I deal with a database, that's probably why.
No, I hear you. I think these are good points. So let's see whether we can go and indeed craft a table with the different considerations and how they apply, because then this is also less of a one size fits all, which is very clearly not working for the edge, right? So it's I think the conclusion that everybody was very likely subscribed to, right? Hey, Andy, thanks for joining. So we just jumped into the discussion on, well, where do these design principles apply, and that we try to go and articulate that, or what we try to go and articulate in the update, and I was just speaking for you, is that the original taxonomy around like different edges that are mostly tied to who owns the thing and then what type of organization is it, is somewhat orthogonal to the design behaviors that we're trying to go and articulate, because a data center in a metropolitan area is different than a data center on a vessel. So you might need to go and design differently. But Kate has a good idea, like saying, well, that maybe not every design principle and not every application behavior necessarily applies for everybody. Yeah. So and maybe we can go and come up with something where we have the different design constraints around like data, around resources, around networking. And I think those were the main pillars, and maybe overlaid with policy. And we have that in table. And then have the design behaviors, and then see whether we can go and do a mix and match. Okay. So that we are less kind of prescriptive about like, there's only black and white, and black and white, obviously, that never exists, right? So there's all kinds of things at the edge that are, say, more diverse, because your edge is different than my edge, and what is central for you is edge for me, and vice versa. So maybe that's a good way to go and express it, so that we're trying to evolve that table a little bit further. And then trying to go and be less than a one size fits all. We can still have all these behaviors, but from an applicability perspective, we are a little bit more diversified, and I think that makes sense. I think I really like the idea. I already kind of forming the table in my head. Not sure whether I'm able to go and put that on paper, but we're gonna go try it.
Hey, you remember we talked last week, and I was saying let's add a column to the tiering for considerations. And so that's what I was thinking. I was thinking along those same lines, but you're coming at it from one end, I'm coming at it from the other end. It was the considerations as they align for each of the different sectors or sections that we have. So for this, you would be ephemeral, you would be less, right? Et cetera, for storage. So yeah, that was the same sort of principle. So even, what's pretty cool about that is we could actually use that as a pivot. So the considerations can be used both for understanding what type of data center you have or what type of edges you have. And they could also be used as a way to connect that back to tiering as well. So it could be the central pivot point. That's cool. I like the idea.
Yeah, let's see whether we can make that happen. I think the point is really well taken. I actually like it. And Julio, you had another point around, yeah, 2 nodes having a shared PV.
Yes, because at the edge, sometimes there are some applications that need higher SLAs. So maybe having a 2-node configuration in case of node failure. But then the problem is the shared PV between the 2 nodes, right? Because Kubernetes usually calls for 3 nodes. That's one consideration. And the other consideration is having a shared storage solution that fits in an edge use case, right? It's that we are facing that challenge, and honestly, we don't find the technology to address it.
Yeah.
So
So if you want kind of RWX style behavior for that,
correct,
shared,
correct.
right? If
correct.
you don't want, if you're happy with read access, then well, that's easier. And you probably don't want to run something insecure as NFS across it, right?
No, we can do NFS. It has to be local.
Okay.
It cannot be remote because the latency is very low. So also the storage has to be local, right? So NFS will work. Anything will work. Anything that is read write. But that's a specific edge use case. So storage is always a big thing, and you were talking about storage, so I remember that use case.
Yeah, which is why we're trying to go and separate the compute piece from like putting something dedicated for storage, because it almost ultimately always ends up being that you're building something that is, if you want to go and persist data for a longer period of time, then you're almost always setting aside a dedicated storage solution.
Yeah, that's one option.
Hmm.
Depends on how much space and power you have available.
Yeah, if it's really small, then yeah, well, it's difficult,
Yes,
right? So
it's
there is some
difficult.
experimental stuff that runs on top of Longhorn, but Longhorn gives you redundancy. It doesn't really give you distributed like Ceph style storage, right? Which is very difficult
Correct.
to do in a very small footprint. Yeah.
Exactly. Ceph is an option, but in a small footprint, it's hard to fit.
Yep.
Yep.
I know. Check. If you have one, let me know.
Sure, I will.
Yeah, we've been looking at, I've been looking at a lot of this Spark and well, actually more Ray context, right? Where, and it's, I guess it's actually, no, you know what? I'll go back. Spark. So Spark and the DAGs that they use, diacyclic something graph. Anyway, I'm losing the name right now. And it's how they distribute the jobs, and then they come back and they can recombine their information, right? But that's not, so that information does not reside or stay on the edge. It's dispatched and then retrieved or sent back to be collected elsewhere. And so but for sharing PVs between edge locations hadn't been one of those things that I was really considering until now. So that's a good point.
Maybe I know this is CNCF, but maybe the solution for edge, just because it's so extreme, doesn't have to be, Kubernetes only, right? We already know it's not. So just anything that works. For example, for database, let's say if we have a remote bank, right? If you have a remote location on the moon and you have to build a local bank, that transaction cannot be lost, right? How do you sync it up? And so to do that, Kubernetes by design doesn't do everything that virtual machine does. So there are areas there still might need to be bare metal and virtual machine. And similarly, the new WebAssembly stuff. Right now, Kubernetes doesn't orchestrate the WebAssembly runtimes, but that's probably going to change with a lot of the working group that's going on right now. So eventually, maybe Kubernetes will orchestrate a WebAssembly workload and being part of the microservices ecosystem. So yeah, especially for Edge, I think it's probably more of whatever works, I would say, instead of just Kubernetes.
I'm curious what you mean by orchestrate in that context,
oh.
given that there's the container deshims that you can use to use kind of normal pod definition of node placement and such.
Yeah, I'd only learned about WebAssembly after joining this team. Actually, no, Katie, you talk about it. So this is my understanding. So there are a lot of right now to work being done in several work groups, so that the WebAssembly can be run directly by Kubernetes instead of having put in within a particular container. So right now, I think for Fermion, for example, you use I think everybody now in the WebAssembly world, you use what is called Nomad, right, from who that HashiCorp, right, to manage the distribution. Is that correct?
Yeah, but with Kubernetes right now, you can use the container deshims, and you make the point that it's inside a container, and that's because it's still using container D, so it has a second level of isolation because it also uses C groups. But yeah, I haven't tuned into the WebAssembly working group that just started to see if they're trying to remove that second level and just natively run WebAssembly. Such as how we do it with Fermion, given that WebAssembly has its own isolation. But I know some people like the second level of isolation. But right now with Kubernetes, you can use the container deshim, and the experience of running WebAssembly is very similarly orchestrated as that of containers. It's just maybe there's work to remove the second layer of isolation. But I do think there's been I'm curious what other level of orchestration they could add, given that it has the same level currently, besides they're working on right now supporting resource limitations with WebAssembly as well. So right now, of course, with containers, you can say only use this much memory, CPU, et cetera. And they're working on adding that same declarativeness to the WebAssembly experience for Kubernetes. Yeah.
I don't know the technical details. I just heard overall what's being worked on. My understanding, I mean, of course, once it's being managed by Kubernetes, it's possible to make it part of the whole, microservices cloud native experience, right? So there could be some overlapping. So what's being described at Edge native could change actually.
Yeah, I think pairing WebAssembly with a Edge Kubernetes distribution is an interesting combo. There's starting to be some demos along those lines around that. I think they posted in the working group channel, maybe. Well, there was a demo recently about doing inferencing in WebAssembly via WebAssembly on the edge, with also IoT discovery. Kind of, we're getting all these really cool demos right now that are the amalgamation of all this work that's coming together. I'll try and find that talk.
Just a quick question, since Kate mentioned about this concept of discovery, right? Is this something that's quite critical in these edge computing scenarios? Because, like, I think I can agree with Victor where you say that you buy a server rack in a data center and things will work because someone's out there to do things for you and provide you the necessary, let's say, parameters, IP addresses, credentials, this and that maybe. But on the other hand, for edge devices, if you have a small enough Raspberry Pi somewhere and it gets lost in the field, is that something that's quite interesting when it comes to like having such kind of self-discovery modes? Or because as far as I understand, there's no such thing that exists for a lot of these kind of devices. If it gets bricked, it gets bricked, and it becomes quite a hassle to debug it or even reach some of these devices when it's on the field, right? So I was wondering if there's something like edge native application, but with an understanding of, I mean, self-discovery in mind. or is it something very far-fetched?
I think there's one aspect that we even have covered in the design behavior, so I can, and Andy added that, which is around like that applications are to understand where they are deployed, so that you need some discovery mechanism of what environments you're deployed into. So in many cases, you need to be cognizant of what's around you if you need to go and connect to sensors or the likes. There is this other aspect about debuggability of the edge. If you assume that, and that's, I think, one of the mantras that we have in this edge native behaviors white paper right now, is that edges are designed to be stateless, then you could basically rebootstrap these edges into their declared state without losing anything. So you can go and treat entire edges like processes in the Kubernetes world. And that makes deployments really easy, because then you don't need to go and worry about like, what is my state in, my edge in from a state perspective. If I can't reach it anymore, I just have somebody go there and hit factory reset or power cycle it, and then you're done. I think that's one of the things that you want to go and design towards, especially in locations where it's difficult to go and reach these locations and operate them, and I even send like IT personnel there. So I think that's something that we articulate right now in the paper.
Stateless thing is another keyword that's I'm still trying to get a grasp of, just being in the community for not too long. For example, Kubernetes is also designed to be stateless when it's first designed, but there are a lot of effort trying to put database running on Kubernetes as a really serious enterprise database data store running on Kubernetes. So it's no longer stateless. So yeah, I guess how do we define stateless when we have a banking application running on an edge?
Now, what do you run on Kubernetes is your problem, right? So end of the day, but I think, but the main design principles for cloud native are indeed like you design processes to be stateless, because you want to go and farm out your state into a persistent store like a database, and be able to retrieve it from there in case you trip over, because otherwise horizontal scalability is just not there. And yes, well, this is like the beautiful clean world. The theory and the reality is somewhere different, right? So that's a design decision that you would ultimately need to go and take. Or, well, nobody forces you to run a database in a cloud native style, right?
Yeah, I don't think we take any specific stance, and this is just going back to the paper that we've been hacking on statefulness versus non-stateful necessarily, right? But the idea is that you know, when you're talking about banking and the potential for you know, data storage or compute at the edge, right? Let's say it's a branch. You want to be, you know, there's all kinds of considerations that you have to be careful with in terms of compliance, right? For the regionality and transfer of data. That, so I put a little more emphasis on compliance and sovereignty and rules that govern the transfer of data in that respect. Less so than I do put on any specific architecture that we might impose as a result of, you know, the work that we're doing. I don't know. Would you agree with that, Frank?
Yeah, and then even more so, right? So we're trying to go and recommend what might be useful to go and have as a goal.
Yeah.
You might not get there, but if you design towards the goal, then your life is definitely simpler than you have a tight linkage between your code and state. If you manage the state as part of your code, then the whole thing is very difficult to scale and very difficult to maintain in many locations. I think that's what we're trying to go and get across. Because at least from my experience with working with a bunch of different software design companies that are building stuff for the edge, they're all hitting the same problems. And it would be nice to go and just make people at least aware of what to think about before you design the application and not after, so that you're not really trying to go and put Mongo into 1,000 different locations and then maintain it and try to go and keep that state consistent. Maybe try to go and run Mongo centrally and then make the edges stateless as much as you can.
I think
Yeah,
that's
the way that I view it is that what we've tried to assemble is as best we could, right, based on our experience so far, has been what do we think would be potential traps, right? That we should maybe put up a warning sign and give you guidance to how you navigate around it.
originally, for example, database on Kubernetes, you use it for like a transient database for caching, right? For running like what is called anyway, just like something you can reload from somewhere else. That's usually the when you run database. But now there's a push to, it's also a really how to say, requirement, right? Because more and more people don't want to run just pure bare metal hardware anymore, and not even virtual machine wherever possible. So, but on the other hand, you have the database. Imagine that you have a database running Kubernetes, and the key is also encrypted, right? The encrypted key needs to be stored in a key store, and that key store is super important because if you lose that key store, everything else is gone, right? In the cloud, in the public cloud, it's not a problem because that is managed and replicated by the public cloud vendors. But now, if you're on the edge, where let's say there's no bare metal, there's no virtual machine, it's pure Kubernetes, you have both the key store and the database running on Kubernetes. So the criticality of that, both the key store and the database, is so important, because if you lose it, it's not backed up anywhere, right? Because there's no easy remote backup solution at the edge. So
that seems more like a design consideration, right? And if I were doing something like that, I might replicate the key store rather than keep it as its own source of truth in one location into a cloud provider.
Yeah,
to provide me some level of redundancy. You know what I mean?
True. Yeah, key store can still be done, but let's say if you have a very intensive application on the edge, have a database, local database, if some part of it at least is so critical you cannot lose it, but there's no, because of network connectivity issue, you don't have a constant backup like you do on a public cloud or even on premise, then having a really a solid hardware that triple mirrored, right? Not losing data become even more important than on premise.
Yeah, well, again, I would probably point that back to another design consideration, right? I mean, if the data is that important, I wouldn't leave it with one copy. I mean, I'm sure you've already thought through this, right? So I'm not telling you anything you don't know, but we're not trying to overcome those types of hurdles, right? Those things but we're trying to give guidance around what maybe you should think about. I mean, if you're looking to impart more, Victor, I really like, what you've done in terms of giving us feedback and input. If there's more there that can be expressed in terms of, hey, look, you might want to make sure that you back up your key store. Hey, look, you might want to make sure that you don't have a single copy of your database running somewhere and maybe have some duplication or some replication scheme. I think that would be really helpful feedback. And we certainly could incorporate something like that. I think those are the types of traps that we're looking to incorporate, Frank, right?
No, definitely.
Victor, that's very
we have
good
more of
feedback.
these behaviors that we want to go and spell out where things are like, yeah, well, go and add another behavior for that or another consideration. That let's go and list them, right? So that's exactly what we're trying to go and achieve here.
Yeah, and I think, Victor, what we didn't write bupkis about a key store, right? Nothing in relation to that. So that would be, I really think that's low-hanging fruit right there. In terms of database considerations, I'm sure we could firm up what we have there to cover it more. So I encourage you to contribute there.
It's an interesting topic. So just like Kate, I think Kate bring up a good, I don't know where, Kate, you got that classification of an edge based on network, resource, and location. That seems to be a good starting point. I'm not sure where you got that. Did you come up with that, the network and resource location classification? And yeah.
When we were writing the last white paper, when we were in the define edge phase, we just were discussing and came to find that everything was one of those three definitions. I believe it might have been someone else, someone in particular who brought it into the discussion now.
I also believe Frank already had a great idea. Maybe have a like different for different classification. There will be different features that apply, like classes for this type, stateless for this type of application, maybe not for that type. And coming back to the backup, for example, if I have a database on the ship, even if I want to back up, but network could be down during the storm, right? For example, right? There's no way to back up. So even if I want to send the really critical information remote, so in that case, the local data becomes super important to be triple mirror protected, stateful for the period at least would be for the backup databases.
But that's exactly what we need to go and then state, right? So that if you really want longer term persistence at the edge and you're afraid that one edge might go down, then that's exactly where Andy was hinting earlier on, that you need replication of state. Maybe you actually put two edges onto the very same vessel, and that these two edges can go and back each other up because they have a mutual reachability, even if the cloud disappear, right? Yeah, well, Andy, nobody can share. That's the problem.
Oh, the host does not.
Anybody here that has the key to the party.
Gotcha. Key to the castle. Got it. All right. So so Victor, so as Frank and as Kate's alluding to, as we're all talking here, that if you had, I know you have access to that white paper. If you look at the illusion we're alluding to where that might come into play is if you scroll down to this section, and I'm in it right now. I wish I could pull you to it, but where it says strategy, definition, tiers, then there was another column that we added last week called considerations. And so what I would imagine there to be there, and I think this is backs up against what Frank was talking about earlier and you supported, was to take each one of these subsections that are here, like disposability, capability, sensitivity, data persistence, and show how there might be specifics that would be considerations that would define further what we mean by that specific row, right? And so in the case of what I have written out there, it's just on the tiering, but it doesn't have to be specific to that. We could talk about it being classifications and categories like Kate has. So I think that's, if you're willing to put pen to paper there, could use your help in figuring that out.
Definitely, it's interesting stuff.
Yeah, and to I think address Victor's point of key stores on such kind of edges. So there are hardware specs out there where you can use concepts like TPMs, where you store the core essential things like certificates and a little bit more than that. Chances are there are much more higher end stuffs that you can now do with TPM v2, I think, if I'm not wrong. So yeah, there are certain so-called security guarantees that the hardware provides on the edge, where you can have certificates in them, or maybe some form of access credentials, which are extremely valuable. Even though if one of the things goes down, the TPM still holds that critical value out there. And I think the other part was beyond the key stores, there are concepts out there now which apply zero trust stuff. I think Philip has left the meeting, but Philip works with OpenZT, and they do have such concepts where it's not just that a certificate on the hardware means that that hardware or that edge is actually a trustful device, right? So there are certain concepts out there like SPIFFE and Spire, where your edge devices proactively work to prove that they are actually the devices that your applications are bound to, for example, connect to, as opposed to just blindfoldedly accepting the certificates. Because in very rare cases, there are chances where certificates can be spoofed too. So you can have a very malicious edge device that something like StuckNext, where someone can plug in a USB device and things can go haywire really quickly. So in order to see these kind of things, I think the concept of zero trust also starts to trickle in these days, although it's a bit too fresh for the edge native landscape because it comes with a lot of complexity to bind it. But yeah, that should answer a lot of questions in the future when it comes to trust on edge native applications.
Yeah, we're doing some work. So in the open source, Kubestellar, which is the project that I represent, we're doing some work with OpenZiti, which allows you to, which they figured out a way to have a TLS-based library that you can just incorporate at your endpoints, right? So both southbound and northbound traffic can be encrypted right out of the gate. So just basically by turning on a feature switch, which is real nice, right? So yeah, I agree. I think in this space is, especially when you're talking about multiple clusters and you know, you can call a cluster whatever you want. You can call it an edge. You can call it an intermediary body or entity. And either way you slice it, you're not guaranteed that you're going to be on the same service provider. So it could be a hyperscaler, it could be AWS, GCP, Azure, IBM, Alibaba, or it could be something more regional. It could be a sovereign cloud. It could be just it could be just somebody hosting a device in a out on some railroad tracks in the middle of Canada. So that all that stuff plays into what is the safety of the network transport, and I think there has to be some consideration there for that sort of thing, right? For an overlay at a minimum. Wouldn't you agree?
Especially if you don't have a TPM on board, right? If you have a
Yeah,
TPM
yeah,
on
right.
board, you can go and chain everything to the TPM, but many of these devices don't come with a TPM, and then things are getting a little bit more dicey.
Yeah.
All the way down to how do you get the certificate there, and how do you then even for simple things like .1x, we see that all the day.
Very good point.
We're running against the top of the hour
Yeah.
because I wanted to go and at least touch on one additional aspect of the paper but unfortunately, I don't think that we have Prakash here, right? Because I'm not sure, because he added to the very end of the document where we started to go and have example scenarios. We made the case for kind of adding 2 additional example scenarios around industrial IoT and telehealth. But he just made the highlight, the kind of the headline for that. What we don't really have any content for that. I'm just wondering whether there's anybody that feels like adding content for that. Because even the summary, I'm not sure whether we want to be that prescriptive about like latencies and bandwidth and whatever, because different applications might behave differently. But if we had more testimonials or initial sample scenarios, that's obviously always beneficial, because it means like people can connect these things more to reality and it's more grounded. If you have examples there. So if somebody feels like he wants to go and throw in an example, that would be awesome. We can go and wait for precaution whether he has something, but we would definitely need to have somebody helping there, if not Prakash.
Is there a deadline for this? I'm curious about before whether we should bump Prakash, which certainly we should do before reallocating it. But yeah, I was curious if there's a certain.
We can go and bug him a little. I think what would be nice is if we set ourselves a mental deadline that we want to have something that is at least ready for next KubeCon. That would be a nice kind of milestone where we can go and say, well, put a line in the sand and say, well, let's get it done by then. And I believe, like, we don't have Brendan here, but he needs a little bit of time to go and work the machinery from an LF perspective to put our words into proper language and get proper layout and all the good stuff that he does.
That makes sense. Since we're at the top of the hour, just a reminder to add your name to the agenda for today if you would like. And then maybe if does anyone have agenda items or things they would like to see in future meetings, certain speakers or topics that you would like folks to reach out to? Just as a last call, we can certainly also add time to discuss some of these use cases the next meeting as well.
If we have them, that would be good.
Is everything okay with Joel? The leader who's usually on the call, is he okay? Everything's good? Or is he? I didn't know he was out.
Dehan and Steve are
Steve, sorry.
yeah, they're both just out today.
Okay.
Yeah, so yeah.
Sorry about that.
But,
Slipped my mind. Thanks, Kate.
No worries. But yeah, so if there's no desires or agenda items for next meeting, we can continue the white paper discussion, birds of a feather. We always fill the time, but if there is something that you would like to see in a meeting, feel free to throw it in chat and we can reach out to folks from different areas as well.
Hey, Kate, point of information, I don't know if you already covered it, but one of the things, and I don't have the note open right now, or I put it in there myself, is do we have is there anything that this working group is looking to promote or put in for the CFP? I think it just closed for North America and for Shanghai for KubeCon. Have those talks already been entered? Is there anything coming out of this working group?
Yeah, the maintainer track sessions for the CFPs, we might still be able to submit something for. I'll check in on that. I've been out for the past few weeks, so I missed some of the past meetings. So I wasn't sure if we'd already covered that. Sounds like we haven't. But yeah, usually the maintainer track sessions are open for a little while after. So I can check in on that. I do know that they've changed that system a little bit to the point where we're not guaranteed a session anymore. Since last KubeCon, that's changed. Before that, as like a working group, you were kind of guaranteed a session. That's no longer the case, but this white paper would have been really good to target for a talk. So let's see if that's still open. And we can see about that. If not, we can certainly set our sights for KubeCon EU, obviously a little less ideal given how far away that is, but yeah, that's a good call out. I'll check into that.
Thanks, Kate.
Can you remind me where the meeting notes reside?
Yes, here, I'll paste it.
I have a terrible time keeping track of these things. Thank you.
No worries. Yeah, and Mark, if you have something that you want to present next session, feel free to throw it on the agenda there. And then for folks who aren't familiar, in order to be an editor of the document, you just have to add the Google group, which is add yourself to the Google group, which is open. So that gives you the rights to edit. All right. Well, thank you everyone for going over, and see you in a couple weeks.
Yeah, thank you. Have a good one.